Assalamu alaikum students, this is Majid Tahir, your teacher for computer science. Welcome to DCode Academy, an essential educational ecosystem. Let's start. The topic that we are doing today is data representation. In this specific topic, we are going to do Denary number systems, binary number systems, and conversions of Denary to binary and binary to Denary. So let's start. So Denary numbers are the numbers that we humans use in our everyday life. So what Denary number system is, we know that in maths, we can have unlimited number of numbers, but actually the possibilities of digits in maths are total 10. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you count all of them, they are basically 10. So all the possibilities completely, totally 10 in math, and we have a base 10 for the Denary number system. So because we have 10 possible numbers in this number system, we have base 10. In your earlier classes, you must have studied place values. So we are going to talk about place values. Let's consider a number. Let's say we have 6,427. Let's suppose we have this number. So base is basically the place values that these numbers are made by the base. So 7 is in ones place. We know that. You must have studied it in earlier classes. 2 is in tens place. 4 is in hundreds place. 6 is in thousands place. Acha. So why 7 is in ones place is because it is 10 raised to power 0. So base is power 0 is 1. Anything raised to power 0 is 1. Then 10 raised to power 1 is 10, then 10 raised to power 2 is 100, then 10 raised to power 3 is 1000, and so on. So when you have a number, the place values increase when you go from right to left and from right to left. Similarly, place values earlier, rightmost side place value is 10 raised to power 0, then we have 10 raised to power 1, then we have 10 raised to power 2, then we have 10 raised to power 3. Now, how the number system is made or how the number is made, that number is multiplied by its place values and added with the other numbers. So every number must be multiplied by its place value. So let's see further how it is done. Again, let's suppose we have another number 6,432. Now in this case, I'm going to write down the place values. So 1, 10, 100, and 1000. So we know that number gets multiplied by its place value. So 6 into 1000, and we have to add that. 4 gets multiplied by its place value, which is 4 into 100. 3 gets multiplied by its place value, which is plus 3 into 10. And 2 gets multiplied by its place value, which is plus 2 into 1. So we get 6,000 plus 400 plus 32. Start them and you can write down your complete number. So this is how the place value, this is how the number system is. Number is made up of place values, and that is how we have to do it. Why we are doing it for the Denary numbers, as you already know it, because when we are going to compute in the binary numbers, this process will help us in the conversion from one number system to another number system. Okay, so let's move forward. So as we have just discussed that humans, we work in the Denary number system or decimal number system, and computers work in the binary number system. Now we are going to discuss what is a binary number system. So the circuits in the computer processor are made up of transistors and capacitors. You have to remember these two terminologies, transistors and capacitors. Now, transistor is a tiny switch. A transistor is a tiny switch that is activated by the electronic signal, or maybe a charge. When it receives a charge in the capacitor, it is switched on, and transistor switched on gives us the binary value of 1. So the binary value of 1 when it is on. And when it switches off, it gives us a binary value of 0. When there is no current in the capacitor, it doesn't switch on the transistor, the value is going to be 0. And we will consider it as off. So we just talked about computer use binary digits 0 and 1 to store data, and we know that there are only two possible states. There are only two possible states in the binary. So as we have just seen that in binary we have only 0 or 1. So there are only two possibilities. So in binary number system, its base is going to be 2. Why 2? Because there are only two numbers. That is why. And options are on or off. So on reflects 1 and off reflects 0. 0 and 1. So 0 is off and 1 is on. The place values of the binary numbers. Let's suppose we have a binary number, this one that you are looking at the screen. So the place value of each number is going to be made by the base. As we know that we have a base 2 raised to power 0. The same formula that we use for the Denary number system. It is going to, anything raised to power 0 gives us 1. Then 2 raised to power 1 is going to give us 2. Then 2 raised to power 2 is going to give 4. 2 raised to power 3 is going to give us 8. 2 raised to power 4 is going to be 16. 2 raised to power 5, 32. 2 raised to power 6, 64, and 2 raised to power 7, 128. Binary number, we have one thing that is important to learn, that every next place value is double of the previous. So when we had 1, next place value is going to be 2, next place value is going to be 4, next place value is going to be 8, next place value is going to be 16, then 32, then 64, then 128. After 128, we'll have 256. After 256, we can have 512. After 512, we have 1024, then 2048, and so on. Every place value is the double of the previous. So it is very easy to remember the place values in binary. Now let's start the conversion. So first of all, we are going to do decimal to binary conversion. There are two methods of converting the numbers. So first method is by dividing the number, Denary number, with the with the base of binary number, which is 2. So first of all, we have 83. Let's see, 83 is to be divided. So 2 times 41 gives us 82, and then 1 goes in the remainder. Again we divide. 2 20s are 40. So this we have 41, so 1 goes in the remainder. Again we can divide. 2 10s are 20. There is no remainder. It is completely divided. So we have a 0 in remainder. 2 5s are 10. Again completely divided. No remainder. So we will have 0. 2 2s are 4. Then 1 goes in the remainder. 2 1s are 2. Again there is no remainder. So 0 comes. 2 zeros are 0, and then take this one in the remainder, and then write them upside down. Means this 1 is going to come first, then this 0, then this 1, then this 0, then this 0, then this 1, then this 1. Now these are 7 bits. 1 2 3 4 5 6 7. So these are 7 bits. If your examiner asks you to write down a complete byte, you can add a 0 on the left side. There is no problem in it. You can add a 0 on the left side. There is no problem. On adding any 0 on the left side will not change the number. But you cannot add any number on the right side. So this is a complete binary number equivalent to this Denary number 83. The second method is very easy if you know the place values. So 1, 2, 4, 8, 16, 32, 64 and 128. I have to make 83. So I have to see what numbers I can choose to add to get 83. Now I know that every number must be multiplied by its place value. So if I put 0 over here, 0 into 128 gives 0. I can put a 64. So 1 into 64 is 64. Now I have a 64. What do I have to add in 64 to give 80? So I take 64 and I take 16. It is 80. Now I need 3 more. So I take 2 and I take 1. And I put 1s underneath that. So rest I can put zeros. Now if you want to convert it back, you can see that 0 multiplied by 128 gives 0, no problem. 1 into 64 gives 64. Again, it's 0 into 32 is going to be 0, no problem. You can skip it. 1 into 16 gives 16. Again, 0 into 8 is going to be 0, you can skip it. 0 into 4 gives 0, you can skip it also. 1 into 2 is going to be 2 and 1 into 1 is going to be 1. So when you add it back, you get 64 plus 16 is 80 and plus 2 plus 1 is 83. So you can get at 83 back. So in this case, you have seen that the number 0, 1, 1. So the number 0, 1, 0, 1, 0, 0, 1, 1. This is a binary equivalent to the number 83, which we have just converted. Now we are going to convert a binary number into a denary number or a decimal number. Again, very simple and easy process. For example, we have this number that you're looking at the screen is a binary number that we are going to convert into a decimal number. Now, first of all, what I'm going to do is I'm going to write down the place value. So 1, 2, 4, 8, 16, 32, 64 and 128. Now, very simple process, the same thing that we just earlier done. Every number must be multiplied by its place value. So 1 into 128 gives me 128 plus 0 into 64 is going to be 0. So I can skip it. 1 into 32 is going to be 32 plus 0 into 16 is going to be 0. So I can skip it. 1 into 8 is going to give me 8 plus 0 into 4, 0 into 2, 0 into 1. It's going to be all 0. So I can just skip it or you can write it. Doesn't make any difference in the number. So the numbers that I have to add now are these. So 128 plus 32 plus 8 is going to give me 168. Now this number 168 is a denary equivalent which has base 10. It is a denary or a decimal number. This is a decimal number equivalent to this binary number that I had 10101000. This is it for today's topic. Thank you so much for paying attention and like the video and share it with your friends.